So yeah, what did everyone think?
I liked it. Okay, I have a question. Kate, why did you leave the other meeting 15 minutes early? Because you had to get ready for this meeting. Did you not read the book?
I did read. I was just recapping. I wanted to make sure I knew what I was going to be talking about.
Okay. No, I just like, I got to prepare, and me and Ava are like, same workshop.
Hey, I was rereading the Blasters chapter about 5 minutes ago, so you're good.
I just wanted to make sure I knew what I was talking about.
Yeah, for some reason it took me forever to read the section. Like, it wasn't, I liked it. It was just like I had other things to do, so that like I didn't recap, but I think I remember most of it.
Yeah. The one thing that I did when I was reading about the Electro staff, the one thing that doesn't make sense, and they explain like the physics behind it. In the movie, you actually see a light, like the lightsaber, being able to like have the same force of the Electro staff, and that wouldn't actually work because they described the lightsaber being plasma, and the plasma would completely just like they wouldn't be able to like connect in a sense. Like the plasma would just cut through the electric, like the actual electric saber or whatever. Electric staff.
Oh yeah, what didn't it hit like the metal, like the center part of it almost?
It hits the electric part, but that still would not work in a sense. Like the plasma and the electric staff, that you wouldn't be able to actually fight with them in real life, or at least to my knowledge. Because as they described it, I think they said the plasma sabers. The sabers were plasma, and if they were like, they're basically extremely, extremely hot. So I don't think if it like connected with electricity like that, as they described it, like a Tesla coil, I don't think that would like be able to block the plasma.
I think I'm looking at it now. It says that because the plasma is a bunch of charged particles, the staff's electric field will exert a force on all of the particles and then will disperse the beam of the lightsaber if the beam of the lightsaber isn't held in place by a containment shield. So if it's held together in some way, then it wouldn't be dispersed. But if it was just like a loose beam, then the electrical force would disperse the charged particles.
Yeah, so it kind of just depends on how the saber was made.
Yeah.
Okay.
Was kind of cool because I'm like, well, Star Wars is really not realistic. Like, it's realistic in a sense, but I'm like, nah, like plasma. Like, how would you be able to hold plasma in your hand? Like, even if it's encased in like a metal protected, no.
Yeah, I mean, obviously they didn't plan it out to be scientifically possible. I guess that's the point of it. It's just meant to be, fictional.
And I think, didn't they say in their world it had to be heated up to like 360,000 degrees?
Yeah.
Plasma, so.
Then if you have a plasma gun, what I thought was really cool is that if they were firing a shot on Earth, which has like a strong electromagnetic field, the plasma bolt would travel in such a tight circle that it would hit the gun that it was shot from, which I thought was really cool because like that obviously doesn't happen in Star Wars.
It's kind of cool because it explains a little bit why like stormtroopers miss so much is because of everything. But yeah, like it's not like none of it's like completely realistic. You can't say that's why that like they're so bad at shooting at people. But it was kind of cool. Yeah. Like the blasters were like, everything else was really interesting, but blasters were super interesting because also like how can they do it in like this little handheld compared to making plasma and everything in like large rooms. I
thought it was interesting.
Yeah, sorry. Yeah,
that's okay. I just had something quick to say that if you have a plasma lightsaber, it would get so hot that like just holding a lightsaber, you would like burn your hand off or something.
Yeah, because it's so hot. Yeah, and then the issue is that sadly, obviously, they said in the book, but it won't be possible in real life for at least a long time due to the fact that they can't make it really handheld.
Yeah.
Because the power, didn't they say it's either the power it takes or the gas it took? They wouldn't be able to like make it handheld in a sense.
I think it was the power. Maybe the power. I can't remember.
Is there a metal that could withstand that heat, or any substance really? Well, I don't know. It's Star Wars land, so
it's like made up elements, made up metal.
They have a different atomic period.
They use something called Tabana gas, which is so they in real life the equivalent would be hydrogen. They'd have to use something called Tabana gas, which I'm guessing it's kind of it's obviously fictional, where it has enough like power to make the lightsaber ignite, and I also think they use it for the blasters as well. But it doesn't actually like it doesn't emit a lot of heat in a sense. So you can still hold it and be next to it, but it's only when you actually touch the saber or the bolt itself is when it burns you.
And it's kind of cool to like think if we can make a weapon, like if we ever make a weapon similar to this, it's gonna be very far in the future. But to think about like that's like such a cool, because it's like it's not like guns where you have to have like ammo and like built up, so you can just use a blaster, use it like a lightsaber, and not have to worry about like refueling or anything like that.
Well, you'd still technically have to refuel a blaster, wouldn't you? Because like it still goes off of some power source or some type of gas.
Yeah.
It wouldn't be actual ammunition that you'd be reloading, but you'd still have to like recharge like batteries or the actual gas and canisters and such. I was thinking about it when I was reading the lightsaber chapter. I just got sad thinking about the fact that even if we do ever make lightsabers, they obviously would never be able to get used in combat because they're so like. The only reason Jedi can use them is they can predict blaster, like when blaster bolts are going to hit them. But in reality, you'd never be able to like actually block a blaster going that speed, which means lightsabers would never be useful. So, yeah.
What I think was pretty cool is when they were talking about how lightsabers, like, they could be either plasma or light. When they were saying that they could be light, that there would need to be like a mirror at the tip of the lightsaber to like reflect the light back in. That the sound that the lightsaber makes when it's ignited could be the mirror shooting out. That was pretty cool to me.
Yeah, like it was kind of cool, like the different ways like blasters and lightsabers are actually like super similar, and like the science behind it, but they're actually like drastically different when used in combat. So I thought that was cool. Is there any other questions like Kate had earlier about the Electro staff that you had on this chapter that hopefully me or Carolyn could answer?
I can't think of questions. One thing that I never knew that I thought it was actually cool, I didn't realize laser was like an actual acronym. They explained it was for light amplification by the stimulated emission of radiation. I thought they just called it laser because it sounded cool. So it's good that they actually have like, it's cool it's an acronym. Yeah. Which I didn't realize.
I think it mentioned that in most cases, like it's become such a common word now, like it doesn't have to be capitalized, but in like older, like not right now, like older text and things, it would be laser all capitals because it was an acronym. So I thought that was cool.
What I thought was
learned that like a couple of years ago, and also SCUBA is an acronym too. Sorry.
That's okay. I was gonna say that when they were talking about seismic charges and how they were trying to address the fact that like in the movie you could see the seismic charge, and then they were talking about sonoluminescence where like the sound actually makes light. I thought that was interesting because the way that they described it with like a bullet slicing through water, I can really picture that, but then trying to imagine how that the energy inside that bubble could emit light, it's like it's made up almost.
Yeah.
I didn't even know that was a thing until I was reading it. Yeah, it was.
It's like there's some things they mention, and especially in like physics and science, that it's so cool that it's hard to imagine. Like that's actually it's not fictional. So that was like kind of hard for a second to like wrap my mind around. Like sound can create light. That doesn't make much sense, but yeah, like it's really cool. Carolyn, your mic's muted.
My dog was barking. What about grenades? What did you guys think about that?
They were like
they had grenades, did they?
They do. They're not as outlandish in a sense. Like they're more believable on how they work because they kind of act very similar to real life grenades.
Well, the plasma grenades, those were.
Oh yeah, those are different.
Yeah. With like trying to figure out how to contain them in such a way that you could contain them safely, but then the containment could also be like popped to release the plasma. That was interesting.
Because it's easier to like think of grenades because like everyone's seen what a grenade looks like. You've seen one explode before. Like it's very like it's not a hard concept to wrap your mind around, like a lightsaber and a blaster, like kind of how it works. But it was really cool, like the encasing, like talking about the encasing and how it would work. I forgot.
The W-54 warheads are the closest that we've come to. I think they said they weigh about 50 pounds.
Wow.
That is really, they would not be like, that would not work in real life.
Yeah, they're launched from a stationary gun, so you can't actually launch them.
Yeah.
Wow.
Because I know in Star Wars they can hold like 3 of them on their belt. That would not work in real life.
Possible here.
Yeah, it's on the lower limit of producing a nuclear explosion. So
Wow. Okay.
the blast radius would be about 170 feet. And the lethal radiation, a quarter mile.
Ooh.
Yikes.
So you couldn't throw it yourself.
No, you would die. You threw it yourself. You'd be in the blast zone. Unless you could throw like really far. Like
yeah.
I don't think, especially since it weighs 50 pounds, I don't think even the strongest person would be able to, no. I mean, it depends on the detonation time. Maybe you could like jog as fast as possible to get out of there, but I don't think that would work either.
I mean, I guess you could be like flying in a ship and then, flying low and then drop it and then fly really fast out of there.
High up really fast, I guess. Depends on how like high. I don't know.
High up you are and how high the blast reaches. Yeah.
I think it was in that kind of segues into like they were talking about. I think it was in here. Okay, so I'm sorry. I'm reading my physics book and then I'm reading this, and so it's like getting confused in my mind. I think they talked about how like mushroom clouds are formed and how that works. They talked about that, right? Yeah. I thought that was like super cool because like clouds and air get kind of confusing. Because I'm like, I always just thought a mushroom cloud was just like the exhaust, I guess, from the spaceship or the
or the dust.
I always thought that was the reason and behind it, and there's actually a different reason that makes more sense than what I thought when I was little. But yeah.
Well, go ahead and explain it.
Okay.
That's what we're here for.
It'll take me a second. So
no,
yeah.
that's fine.
I promise I read this. It's just there was so much information in like that little span. Okay. Another interesting consequence of shockwave passing through air is cloud formation. Air can only hold a certain amount of water vapor without condensing into a cloud. How much water vapor the air can hold mostly depends on the temperature and pressure of the air. When a compression wave passes through heat air, the pressure momentarily increases significantly and then decreases. This spike in pressure causes water vapor in the region of high pressure to coalesce. COALESCE. I don't know how to pronounce it. Sorry. Yeah. Into a cloud, like transform into a cloud. Essentially, this can be seen along shock waves of. For example, a large explosion causes mushroom clouds. Sorry. Yes, you can. I did.
Can you repeat like the last like 10 seconds? You were a robot for me. I don't know.
Oh yeah. Sorry. I guess what was I talking about when I went all robot?
It was like the last 10 seconds. That was it. So count back 10 more. How many seconds? How many words do you read per second?
This spike in pressure causes the water vapor in the regions of high pressure to create a cloud, essentially. This can be seen along the shock wave of explosions or around jets traveling at supersonic speeds. Certain types of explosions can create different kinds of clouds. For example, a large explosion causes mushroom clouds. Kind I guess it doesn't really explain why. 1 second.
Well, the water vapor
Yeah.
not being able to hold. I was going to show you guys. Have you guys seen Chernobyl, that HBO miniseries?
I haven't seen the mini.
I've not.
I know what you're talking
Oh,
about.
it's so good. But this happened when I was like a little kid, but that's how old I am. Oh no, I don't have. I thought I had a picture of it. But it shows you like the reactor blue. So you're mostly thinking, it's what you said. So you're mostly thinking that that's just the dust that comes up from the explosion, like the bomb hitting the ground or whatever and exploding. But when that reactor melted down, it did the same. Let's see if let me share my screen. And that's a really, actually, just as a side note, that's a really good movie. Or a really good miniseries. I talked to Michael maybe about doing a thing on nuclear reactors and on history, because that would be cool. But see how it goes up and then it like plumes out. Think about a volcano. It does the exact same thing. So it's because of water vapor, and that's one of the things that's dangerous. The most dangerous thing about this is it starts to end up in the clouds. And Chernobyl, when that reactor exploded, it covered most of Europe at one point. Not as deadly as it was right at ground zero and stuff, but and if you think back, to like volcanoes erupting, it's all going to be that, and it has to do with the water vapor right above wherever it's happened, not being able to hold enough moisture in the air, so it starts to move out. But yeah, that's just a side note. Sorry.
No.
Carry on.
I just segues. You said something about a volcano, and during like the seismic charges. At the end, they talk about the volcano that exploded in like 1983, and I thought it was like so cool that sound they could read it. Sorry, one second.
Didn't they hear it in like Australia or something?
Yeah, in Sydney, and then some instruments were measured the shockwave as many as 7 times because it left in all directions and like circled the globe like 3 times, which is like mind-boggling. Just like, sound for like 7 days is just crazy. And Sailor's aerodromes 40 miles away were ruptured, which is like 40 miles away is like very, very far.
Yeah, it is.
Because 40 miles from Atlanta is like, I think, 40 miles from Atlanta is like maybe way across South Georgia. So it's like, that is not 40 miles. That's too far. But it's a long way, especially like because these sailors probably didn't even see it coming because 40 miles at sea is like far. Like you can't see that far.
Yeah, and they have no idea what's happened. Just imagine. You're like, something ruptures your eardrum and you don't see it. You don't know what it is. That's crazy.
Especially in 1883 when they didn't have the technology we do now, because like now we have all of this technology that they would probably know it was about to erupt and everything.
Yeah.
But yeah. Sorry, that was a side note.
That's okay. That's
I thought that the Faraday cages were really cool, that you could be in the fight with a person wielding an electrostaff, and then they could hit you with it. But if you were wearing chainmail, the electricity would just, it would go through the chainmail to the ground instead of through your body.
Yeah, no, I like
and
that.
It's so counterintuitive because you would think that, like you're touching the metal, so it would go through your body. But I thought that was interesting, and that's why it's safe for you to be in the car when there's a thunderstorm, not because the rubber tires will just charge everything, will discourage the lightning strikes, but because the lightning will just go through the metal frame of the car and not you.
I liked how they could talk about like kind of into that. They were talking about how like electricity's kind of lazy and it doesn't work hard to like get to things. So I don't know if you've ever heard, but if you're ever out in like an open field or like near trees, you always want to like get down on your stomach or get as low as you possibly can, because it will strike the tallest thing. So if you're by a tree, don't touch the tree if it's the tallest tree, or just like try not to touch things that are tall and can conduct electricity. I just thought that was like cool, because electricity is way lazier than you think it is, because it always feels like it's out to get you. Don't touch a socket, don't get near a socket, like that type of thing. So yeah, if that makes any sense.
It does. Do we want to talk about what chapter we're gonna read
Yeah,
next?
we can talk about that if Carolyn doesn't have any other questions about like this chapter.
Oh, you're on mute.
I keep having people walk through here. My office is like in the middle of the front side of the house. Did you guys understand like mass to power? I mean, we kind of talked about that, and that was, you know, when we're talking about the grenades. I'm just looking through the science parts of it. I feel like you guys had a handle on that, and about plasma.
I thought that the mass to power was cool, because it said that converting a ping pong ball's mass to energy would be equivalent to a 43 kiloton explosion, which, like, a ping pong ball is not that big.
Yeah.
No. So think about like Hiroshima when they dropped that. I mean, it wasn't that big, right? I mean, those little warheads are not as big as the explosion that they cause. It's kind of crazy. But, you know, splitting atoms, that's a whole other day.
Splitting atoms is intense, and fusing atoms is intense too. Like, oh gosh.
I feel like we should make, you know, a Sora project. Let's
create a nuke.
We're gonna heat plasma up to 3. Tell Wesley and Garrett we need some extra insurance, because we're gonna heat plasma up to 360,000 degrees and see if we can find a container to hold it.
Fuse atoms, just which is literally the
For Hannah's rocket, we're gonna blast it off with plasma.
It's kind of funny because we were talking about all this rocket stuff, and I'm like, that's too dangerous. Like, we're always like, okay, no, that's too dangerous. No, don't think about it.
And what's so funny is then they talk about the next chapter is heavy weaponry, but all the stuff that they were using for handheld weaponry is like
so dangerous.
I know, compares to a nuclear explosion, it's like crazy. I'm like, I can't imagine what the heavy weaponry is going to be like.
I think it's the Death Star.
It's ion cannons. It's pretty cool. So I guess the next step is to look at what you guys want to do for next week. It's up to y'all. I'm just here.
Yeah. I think heavy weaponry could be cool. The Force.
The Force would be pretty cool, because
that'd be pretty cool. There's a lot of physics in, like, not necessarily the Force, but Force in general.
Is that the next chapter, or
it is the chapter after heavy weaponry?
Okay.
Yeah.
Okay. Let me get over there. I want to see what. Oh my gosh! Why did I buy this on a Kindle? This is like annoying.
Yeah, Kindles. I love Kindles, but sometimes I'm like, I need a book. I just need to flip through it.
I do too, but I have it because, like, I'll wake up in the middle of the night and I want to read. It's like backlit, you know, so I don't bother anybody. But okay, so it's talking about Force. Well, I was gonna see the physics concept of the Force is Force. So, energy and gravity. So these are the ones you're gonna take a look at. It's been a long morning. Force, energy, gravity, and is it just one chapter, or is it divided up like
I think it's just one chapter on like the Force.
Force lightning. Is that a separate chapter, or let's see?
I think that's.
I think
the
it's
same
like a thing inside the Force chapter.
Okay, that's electricity, which we kind of already hit on today. Sorry, it took me 3 years to.
You know, they have the force lightning, force jump.
They have the frozen blaster bolt, which is pretty cool, which is like, it relates back to what we were just learning with like freezing a blaster bolt in midair.
Sorry, you suddenly turned like super red, just red and then white background.
Hey, did you know about the Lichtenberg scar? That's interesting.
I did not.
That's the scar you get by a large electrical discharge.
Oh yeah. Oh, those scars are like the craziest scars.
I had a friend from high school. This is a terrible story. Like
Oh,
4 or
no.
5 years ago, he was out jogging and he got struck by lightning and died. It was,
Yikes.
I know, it was so random. Like,
Yeah.
Uh-huh.
I mean, so everybody was like on social media, oh my God. I was like, what are the odds, Hannah? Do you have them calculated of being struck by lightning?
I don't personally have the odds. I've known a lot of people who known people who died.
Yeah. I mean, he wasn't really a friend of mine. I just knew who he was, but I was just like,
I knew someone who a close friend died by picking up the phone during a bad storm, and she got electrocuted and died from picking up a landline. Yeah.
Well, I don't have a landline. So.
Yeah, I was like, what's the landline when I was
I'm always telling my kids, though, I'm like, you can't take a bath. And I don't know if that's true or not either.
I'm always like, can I take a shower right now? Because it's storming really hard.
You'd think I would know that. Like, I would, but I still believe stuff people tell me. Like, even if I don't believe it scientifically, I'm like, you know, you always think, like in an airplane, you're always thinking, oh, the statistics say that me dying in this airplane, it's more likely that I'm going to get killed on the way to the airport, you know, in the car. But then you're like in a giant tin thing flying through the air, and you're like, and I understand aerodynamics, but I'm like,
I'm gonna die.
Yeah. I'm not that bad because I used to travel for work, but I was before I started traveling. Then I just kind of got used to it. But I still do that when I'm on a flight. I'm like,
Yeah.
You can understand all the science, but you're still like, I'm in a giant tin can 30,000 feet in the air. This does not seem right.
It's kind of the same thing with like needles and
oh yeah,
you're like, oh my gosh, I'm gonna die. You're okay.
Yeah.
You know what they're doing.
Yeah.
To help you.
Okay, so you guys are gonna do the Force. Yeah, it has a few different sections. I'll go through it and find some videos and stuff and post what skills we'll be going through next week, just so you guys can kind of watch it and then you can read it. You guys did an amazing job today. I'm just like floored.